tab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? What's up? Zach's here. Nice. And Machka last. You ain't first, you're last. Oh, wow, we already got 2 questions in the queue? Wow. All right. I'll keep things short and sweet then. We'll get to work. Let's see. I made some announcements in the Discord, so if you didn't see them, go check them out. Quick things. I can probably just like say some things real quick, right? Let's see. Yeah, what was it? Okay. Yeah, quick little recap. We had some fun new streams yesterday. Narosky and Ramton. Thank you to those two for kicking off. We had the Gilded Method and we had the Golden Hour streams, and so we created 2 new channels there. If you want to go discuss, I also posted the recordings to those streams, so you can go back if you missed them. The next one will be in not this week, but the next week. I'm thinking about doing these every 2 weeks, just to kind of like spread things out. I hate like audience exhaustion and also my own exhaustion. So it's fun when things are special because, you know, they're every once in a while, not every single day, and then people get a little saturated with it. But homework's every day, so that's why we do office hours a lot, because you guys always have homework that you need help with. Let's see, what else? Chess tournament. Yeah, that was really fun. I think we had like, I want to say 9 people join the chess tournament last week. That was super successful, especially for like only a day's notice. So you guys can vote on this week's game coming up. You can vote on chess if you want. If chess doesn't win, I will probably make chess the de facto game for the following week. And then that way we have a little bit more of a head start. There is a stream tomorrow. What's wrong with tomorrow? Today's Monday. There's a stream tomorrow. Yeah, anytime you want to see when the stream is, you know where the calendar is, right? Calendar's over here. There's definitely a stream tomorrow. Yeah. There it is. That's the stream. There's no, there's going to be no Golden Hour or Narosky stream this week. Next week, I'll do it again. I'm thinking about doing it every 2 weeks. Unless, you know, people really, really want me to do it every week. And then I'll consider it. But anyways, so, yeah. Also, if you're in the actual resolutions challenge, I know there's like 20 of you guys in this. We're officially halfway through the first month. So make sure, go check your DMs, because I DM'd you what you said your goals were and what you were trying to do this first month. And so start lining yourself up. This is some odd choice of words. I use ChatGPT to like kind of help me write these announcements, but yeah, I'm gonna fix that. I would never fucking say lining yourself up. What? I would say start getting on track for we're gonna have a little bonus on after the first month to see how you guys are doing. And yeah, big reminder, it's okay if you're behind. Don't worry. I would say don't let perfection be the enemy of good. We're just trying to make some progress. So as long as you're moving forward and you're a better person than you were yesterday.
That's dope.
Dubs. Okay. Any questions, comments, general rat, yappery? Use the thread. Say hi to me. What's up, nerds? What's the link again to submit questions? It's always right there. It's actualofficehours.com. I tried to make it a very easy domain, right? Yeah. And then there you go. Riley's like, I got a fun one for you. Oh dear. Oh dear. Okay. All right. That being said, looks like we already got 2 questions in the queue, so let's start it on up. Get you guys some help, and here we go. All right. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is the live stream that helps you out with math homework, science homework. All sorts of fun stuff. Let's get you going on TikTok. Let's get you going on Twitch. Geometric series dubs. Yeah, we do got some geometric series coming up, I guess. Also, why is my chat not reading correctly? I gotta go fix that. Alright, one sec. First question in the queue is from Mike. Find the equation of the derivative. This is quite simple. Thank you. I love the softballs. Whose question is this? Should I make them use the limit definition of the derivative? Just like make this like extra fun. Looks like me and my chat's running. TikTok's running, and then here's YouTube Shorts. Good. Yes. Yes. Okay, and I need to fix this. I don't know why we're not getting. There it is. I need to fix this. Let me delete this one. Social stream doesn't want to work? Man, really? Okay. That's odd. I'll have to see. I think TikTok's blocking me using external chat things on it. Okay, whatever. But we'll figure it out later. You use use substitution? I don't think so. I don't think so. Okay. Let's see what we got. This is simple power rule stuff. So 3x squared plus 2x plus 4. Take the power, multiply it down out front, drop the power by 1. So this becomes 2 times 3x. And then this drops down to the first power. Then, anytime you have something just x with no power on it, this is the same thing as like x to the first. Make them do it with Newton's quotient. Is that the limit definition of a derivative? I might do it. I might just do it for shits and giggles. Okay. Because when this one happens, right? This comes out front. So now you're going to have 1 times this, and then this drops down to 0. And then the cool thing about x to the 0, that's the same thing as just 1. Okay, and then we have plus this. Well, this doesn't have an x on it, so the derivative of this is 0. But if you want to see why that is, just having nothing, like no x's on it, like just a 1 like this, is the same thing as like x to the 0. Okay? And you can then pull this down. So then you get 0 times, I guess this would be 4x technically to the minus 1. But 0 times whatever is 0. So this just goes away. So eventually what you're left with is 6x to the first, which is the same as 6x, and then this is plus 2. What's 0 to the 0? I think that's undefined. I think 0 to the 0 is undefined, right? Is it 1? Oh, it is 1. Oh, okay, cool.
Oh no.
I got that wrong. Thanks, 6-Lip. I didn't know that. No, the 6-foot feminist is back.
That's dope.
What's up? Yeah, I know 0 factorial is equal to 1, I believe, right? This is equal to 1. Yes, Sam. Yeah, good. Yeah, so f prime of x. Okay, yeah, technically you have to write that. F prime of x would be equal to this. Super easy. 0 to 0 is not defined? Well, there's a little bit of a debate going on here. Some people think it is, honestly. Some people would disagree with you, Jeff, there. Oh, I can't see this. One sec, I want to try something. Because I really want everyone on TikTok to also be able to see the chat. No, it's just blank. Interesting. Okay, one sec. Let me fix that. That needs to be fixed. Where's my chat? No, not that one. Where is it? My chat box. One sec. I'm gonna find it. Where is it? There it is. It's this one. Okay, there we go. One sec. Let me grab this. I need this to be correct. Oh, wait, cancel. Okay. Here. I want to fix this. No. Because there are multiple equations that converge to 0 to 0, and those are equal to 1. Oh. Okay. Oh, are there multiple different ones? And then that's why it's undefined? Because you can't have things converging to different stuff? I think that's what we're kind of saying. I want to see why this doesn't work. She said it was undefined. Okay. I'll agree with it. Sorry, I really want this to work, though. There we go. Oh, I saw it. I saw it for a second. Yes. Okay. I think we got chat working again. It's like upside down though. There we go. One sec. I think I got it. I think I got the chat for you guys. Oh, there we go. There we go. Okay. All right. It's not perfect, but it works. There you go, TikTok. Now you guys can see what everyone else in the chat has. I was like, that's super annoying. It wasn't loading. I'll make it look nicer later. Okay, cool. All right, great. Good first question. Go.
Well done.
All right, let's mark that as done. That was from Mike. We're gonna go put that in our Discord. So again, if you guys have any questions, you want to submit them to the queue. The website right there is actualofficehours.com. Go click on it. So it's very easy. You just go there, type in your username, type in something that I can recognize you on one of the chat clients, right? If your name is like Blue Box, whatever on TikTok, don't put like Pink Dragon, like as your username. Put it something so I can tell who the fuck you are. And then if you want to join our Discord here, every time we do one of these questions, I'm gonna post the solution here into Discord. So here, let me get the screenshot for the person we did here. This was Mike. There we go. Good. And then here's the solution to Mike's question. Downloads. There we go. There you go. Good job, Mike. Okay. All right, let's see what we got next on the queue. Anthony. Ooh, nice. I like this. This is the limit definition of a derivative, Anthony. Let me see what definition they use. There are two different ways to do it. Ah, okay, yeah, I think I do like this one. This definition I like. I don't like the one where it's like the limit as like, I think it's, I want to say it's x approaches a, right? And then it's like f of a minus f of x over like x minus a. Like, this one's gross. I get that it's kind of the same as this, but it's much nicer when it's like the limit as h approaches 0. This is the limit definition of the derivative, yes, but there's two different forms to it. That you guys learn in like school. Yeah, there's these two forms. They're very similar. But I just find the one where it approaches a to be like confusing. For whatever reason, this way like fucks students up. This way makes more sense. I get it. I know you're just doing like a substitution of variables, but trust. Yes, 6 foot. Did you send it? What's your username? Okay, nice. You're number 5 in the queue. I'll get to it. Just hang around. Don't worry. We got 2 hours. All right, here we go. The second one should have a minus. Yeah, you're right. This is not a...
Disqualified.
Dude, calcworkshop.com, dude. Get your stuff together, dude.
Oh shit, not good.
Yeah, that's wrong. What's that, Wavy Chris? Okay. Determine the slope of the tangent of the curve at the point using limits. Great. Okay. Where x equals 3. All right, so slope of the tangent line, that's this. So we're going to have to take the limit. This is... Okay, so first of all, I don't have enough room here to do this. This is criminal, dude. How are you supposed to do this in this small amount of room?
Oh shit, not good.
No. There's no room for that. Okay, here we go. All right. Slope. And we could say like at x, let's just say at x, okay. That's equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And how this makes sense is this is the slope between 2 points where, real quick, if I were just to like draw it, let's say this is f of x, right? So some point here at x, here I really should say like f of whatever, I'm gonna leave it as x. This right here is f of x. Yes, you could do that as well. Yeah, that would be valid. But then that's just more work. We don't need to do that. And then this right here is f of x plus h. And so if you want the slope between these 2 points, right, that's y minus y. That's what this is. Over x minus x. And then x plus h minus x just gets you h. And then what you're doing is you're taking the limit. Notice this h is like the distance between this x and this x. So as that h goes to 0, eventually the slope between those 2 points becomes what we say like is the instantaneous slope here. That's the I don't know, the visualization of what's going on. You were trolling. I mean, it would work. Okay. But anyways, mechanically how you do this, all you have to do is you have to calculate 2 things really, and then we have to do some algebra to make things look nice. So first thing I'm going to do is figure out what f of x plus h is. Okay, so f of x plus h, which maybe sometimes actually it's easier. Let's just get f of x first. So first of all, f of x, right? That's going to be equal to negative x squared plus 4. What's up, oh, Jamarcus, dude. What's up, dude? I haven't seen you in a while. What's cracking, dude? How's your super advanced smart school? Okay, and then here, for x of x plus h, there's a reason why I color-coded this. It's not just because I'm autistic and I like colors. It's because anytime I see that x here, I'm going to replace whatever is in here. So, for instance, f of x plus h means, instead of saying negative just x squared, I'm going to do negative x plus h. And then this is all going to be squared. Oh, you sent over a question? Yeah, cool. I'll ping you. Yeah. 4, and then this is x plus h, again for this. And then we still have just like plus 1. Cool. All right, so now that we've got that, what's the difference between dy dx and ddx? Good question. So dy dx tells you that you're already taking the derivative of y with respect to x, whereas ddx is like open. Like single, ready to mingle. It can act on anything, but it hasn't chosen yet. Dy dx is already doing a derivative on y equals something. That's what like dy dx means. It means you've already picked it. Like dz dx is the same thing as ddx on a function z that is dependent on x, hopefully. Yeah. Yes, I did Psycho. Oh, hell no.
Surprise, motherfucker.
All right, here we go. Let's plug stuff in. So, we're going to do this. And then we're going to do minus this. Right? Now, here's the key thing. This is the thing people always mistake. Always get wrong. This minus sign needs to hit everything inside f of x. What's up, Shriram? So this minus hits the whole f of x, which sometimes it'll help to put parentheses around this. Just kind of a good way. I predict Dr. Gold will skip Riley's question. Is it like something super engineering type shit? Then like I probably will. So this minus is going to distribute into everything of f of x here. You be careful with that. It's something that students always mess up on. It's a weird systems. Okay. Okay, and then this is all over h. Okay. Bro, it's fun.
Surprise, motherfucker.
It might not be. Okay. All right, so next step is to expand. So let's expand this all out. All right, so this ends up being negative, and then x plus h squared is the same thing as x squared plus 2xh plus h squared. And then I'm going to distribute this stuff as well. So then this is plus 4x plus 4h, and then plus 1, and then here comes the minus stuff in. So minus is plus x squared minus 4x minus 1. And then this is all over h. Okay. Sometimes it'll help actually. Let's bring this minus sign inside all this stuff as well. Okay, so then I have negative x squared minus 2xh minus h squared. Right? And then this is plus 4x plus 4h plus 1 plus x squared minus 4x minus 1 all over h. Now here's a cool thing. Right now, like right here, for instance, if I were to take the limit right away as h approaches 0, I would have a bad time.
Disqualified.
Because I would end up getting 0 on the bottom, right? And then this would cancel with this, and I would just get 0 on the top as well, which is bad. So what we have to do is we have to do a little bit of algebra. So if you expand everything out and then do some algebraic cancellation stuff, there's actually some really pretty things that happen. So watch. You have minus x squared. You have plus x squared. That goes away. You have plus 1 minus 1. That goes away. And you have plus 4x and you have minus 4x. That goes away. So all you're left with here is minus 2xh minus h squared plus 4h all over h. Yeah, exactly. And dude, there's always the debate of whether Leibniz or Newton got it first, right? Don't they always like debate each other? Like, no, I did it. Or, no, I did it. Because they discovered it simultaneously, but also at different parts of Europe, and also we didn't have the internet back then, so... Question is, like, how did they both... It's actually really cool. It's a cool debate for, like, who got it first. Okay. Cool thing here. I can factor out h. This will almost always happen with limit definition of derivative. We can factor out h out of everything. So then I have h. And then this is negative 2x minus h plus 4. All over h. H's cancel.
Good job.
And now what we're left with is something much nicer. So this h on the bottom, dividing by 0, which was giving us a hard time, is now gone. And we have just minus 2x minus h plus 4. Now if you plug h is equal to 0, you end up getting negative 2x plus 4. And this is equal to f prime of x, which is going to be the slope at x. So actually, maybe I should have said, yeah, slope at x, same thing. Yeah, f prime of x. Which all of this work, I know, this looks like this sucks, right? All of this work could have been done a lot easier by just doing the power method here, where again, just drop the power, and you just get f prime of x is equal to negative 2x plus 4. Which I think is, yeah, look, same answer we got here. So, both work. This is, I don't know, the builds character method that teachers have you do to try to, like, see where it comes from. I missed something. What I miss, dog? What did I mix? Is it a plus C? Well, I haven't done it yet. I still have to plug in 3. But the derivative's done so far. Yes, exactly, Anthony. That is correct. Yeah, I haven't done that yet. Yeah, so that's the derivative. So that's the slope at x. But then they want it at 3. So then you just got to plug in 3. So f prime of x is equal to negative 2x plus 4. Then f prime of 3 is going to be equal to negative 2 times 3 plus 4. That's going to be equal to negative 6 plus 4, which is equal to negative 2. And you're done with that part. Newton was so mid, dude didn't even use the power rule.
Disqualified.
My way is so much easier than my teachers. I think it's the same way. What are your teachers doing? Are your teachers doing something other than this? I'm curious. What are they doing? So I want to fix my chat. Oh my god, that chat's so long. Why is it so long? I need to fix this. 1 sec. Settings. The TikTok like streaming client is pretty terrible, honestly. It's custom resolution. I need the height to be like way down, dude. I can have this at like 300. There we go. Yeah, that's what I want. Much better. No, a little bit less actually. I had like 200, 250 maybe? No. There we go. Okay, that looks fine. All right. Your teacher plugs in 3 first?
Surprise, motherfucker.
No, you can't do that. No. What? Dude, that's rage bait, dude. What? Excuse me? Yeah. Am I deliberately on Just Chatting? Yes, because there really is no... Just Chatting has a lot more people in it. It's better for exposure on... And we are just chatting, right? We're just chatting about math. I don't think there's actually really a math category yet, or an education category in Twitch. I've tried the lobby for it. I literally talked to the CEO of Twitch. And he said he'd get back to me. He never did. Man's a liar, Dan. Why didn't Newton just ask chat? Yeah, good question, dude. He's a plebe. Alright. Determine the equation of the tangent. Okay. Well, this is y equals mx plus b. You already got m, right? M is equal to -2. So you have y is equal to -2x plus b. Now, in order to get the intercept, you need to figure out what the point is where you're trying to figure out your tangent line is. So here, we're going to plug in f of 3. And that gets me -3, or -3 squared plus 4 times 3 plus 1. So that gets me -9 plus 12 plus 1. That's 3 plus 1. That's equal to 4.
Nice.
So the coordinate 3, 4 is actually on the curve. And if I need the tangent line to also be on the curve, then I need to plug in those points. So this is 4 is equal to -2 times 3 plus b. 4 equals -6 plus b. B is equal to 10. So your final equation is y is equal to -2x plus 10. And there you go. You're done.
Well done.
6 was feminist. It's skip.
Well done.
Oh yeah. The other reason I'm on Just Chatting is to compete with the feet pick thirst traps. Yeah, we're trying to invade with educational content and science and math. Because I know y'all are scrolling there anyways. We're doing the Lord's work. It's like a missionary thing. we're trying to convert people. All right, whose was this? Anthony. Good question, Anthony. Anthony, if you want to get credit in my Discord, because every time you ask 10 questions in our Discord, I buy you a $10 gift card. Go join. Go claim it. Wait, that wasn't Anthony. Sorry. Mike. Wait, that was Mike. So wait, let me post yours. Can you put... Is yours next? I think Riley's is next, but I might skip Riley's right away.
Oh shit, not good.
We're gonna see. Give me a second. Sorry. Give me a second. I'm putting Anthony's in. Professor Holden is golden, bro. What a man of the people. Tough soundboard. Thank you, Bart. Okay. Let's see. What else is on the schedule? We got Riley. Okay. All parts of the problem pertain to the interconnected system of parameters A and B denote adjustable revalued gains. Okay. Verify that the system has a closed loop transfer function from X to Y given by... This is fascinating, dude. Yes, IKEA. Well, there is a pattern to getting row reduced echelon form. It's called Gauss-Jordan elimination. There is a pattern that you can follow, and that's what calculators do. Okay. Yeah, I don't know how to do this, dude. What? Do you just, multiply this by this? Is that what you do? You do 1 over S plus A times 1 over S plus A times 1 over B squared? I don't know what the back system is here. Also, what class is this for, dog? It could just be functional composition. Yeah, maybe. Yeah, this almost looks like it, right? 1 over S plus A squared is 1 over S squared plus 2AS plus A squared. But then I don't understand where the 1 over B squared comes from. This is called linear systems and signals. Oh, cool. Okay, well, I'll put it in our Discord. If someone who is in engineering class wants to, help out Riley with it, I'll put it there. Otherwise, cool. This is a textbook signals course? Cool. I might come back to it later. Let me see. The queue's getting long already. Let me see. What does Pi got for me? Ooh, all right. A tricky integral. Looks like a Laplace transform. Yeah, kind of. Laplace transforms are used a lot with signals and systems. So I will agree with that. Integral, you say? We do love integrals. All right, here we go. Log of x minus 1 over 1 plus log of x squared all squared dx. Oh, man. Yeah, this looks kind of tough. Oh, jeez. I'm going to convert everything to ln just because usually log in math land just means ln. Okay, so ln of x minus 1 over 1 plus ln of x squared. And then all this is squared. Then dx, and this is an integral. My gut instinct, anytime I see 1 over like 1 plus a squared, I think about tangent. That's my gut instinct. And then maybe this comes up somehow. No, Psychode is a person. Psychode's definitely a person. Ellen is toxic.
Disqualified.
Like Ellen DeGeneres. Ellen. What if it was like Ellen Degenerate or something? I don't know. I'm trying to find. We're all still undecided. Ellen of Troy. Ellen of Troy. Oh,
Good job.
that's another good one. Apparently, there's a lot of debate over like who they cast for Helen of Troy. Helen of Troy. Apparently. There's no 1 over x for u. Yeah, u equals ln of x. If you can see the derivative somewhere else, it works. So, you could say, for instance, u is equal to. What if we did like ln of x? And then du would be equal to 1 over ln of x. What if it was ln of x minus 1? Okay. Times 1 over x. Okay, wait. 1 over x. This is getting kind of close. Sorry, this would be ln of x minus 1, right? Times 1 over ln of x minus 1 times the derivative of ln of x is just 1 over x. Yeah, that doesn't really help us though. And then I was hoping like maybe this would flip somewhere, right? And this is like dx. Okay. I don't know. Sometimes I get some fun little math warriors on YouTube that just give me ridiculous questions. But in that case, let's get chat to give us some intuition. If chat gives me the first step, I might be able to do it. If x equals e to the u, then dx is e to the u du. Uh-huh. But how does it... Oh, and then you want me to do ln of e to the u? Yeah, let's see. So, chat is trying to see if it can show that it's the integral of a derivative. Pi, if you submitted this question you don't know and you have any hints, I'd appreciate some hints. Don't leave me struggling here. Chat's like, I've already tried a couple substitution. It's not fucking working. Maybe I need to adjust my approach further. Integration by parts? Oh, I don't know. Yeah, at this point, this is just people giving me questions to derail me, which is like, okay. Let f of x equal 1 plus ln of x squared. F prime of x is that. Okay. That's cute. I guess it works. Oh, nice, Gladiator. Cotton Chem. Yeah, this is... I don't know. This is kind of garbo, doing this. You're just guessing a solution, which, like... Congratulations. Like, what? I don't know. That doesn't really show to me any skill in math. It just shows you got fucking lucky. Like, how the fuck are you supposed to just guess this? But I guess it works, right? I don't want to take the derivative of this, but sure, okay. Because that's what it's basically saying. It's saying that the derivative of this is literally the integral. Yeah, this is just kind of a pain to do the derivative of. Okay. So, maybe this, maybe that. Nice, it's right. Yeah. I don't know, that's just, that to me screams like JEE, screams just like the wrong way to teach math. Because guessing and checking is just abusive. No, I agree. Like, differential equations is a lot of guess and checking, but at least there's intuition, right? You say this looks like a first order, or this looks separable, or this looks homogeneous, or this looks like it's whatever, and then you apply a technique. This is just randomly guess, like, some random derivative. I'm sure Wolfram gave the answer instantly. Is there an intuitive way to solve it? Yeah, guess and check. Yeah, dude's garbage. Yeah, this is like, okay, you know, let's try. Might have been able to use, okay, see, there we go. If someone tells me, like, you could have used a power series or something, I like that. That would be a cool way to solve it. But okay, here, we can just try it. Let's just do f prime of x. What would the derivative of this be? So this is a quotient rule, right? So derivative of the top times the bottom. So that's just going to be 1 times 1 plus ln of x. Can I just say ln squared of x? I'm going to do this. I know this looks like illegal, but whatever. No. Minus the first times the derivative of the second. It's a little weird. So this is 2 ln of x. And then times the derivative of ln of x, which is 1 over x. Oh, okay, so this actually goes away. Nice.
Good job.
Right? 2 ln of x times derivative of ln of x is 1 over x. Okay. And then this is all over the bottom thing squared. So 1 plus ln of x, ln squared of x. I'm just going to call it ln. A lot of times in math, when they write log, they actually mean ln. You have to say like log base 10 for what we traditionally think ln is. What we traditionally think log is. You can assume it's just ln. Yeah, math nerds use it. So yeah, so what do we get here? So we get 1 plus ln squared of x minus 2 ln of x over 1 plus ln squared of x squared, right? And what, we're trying to make it look like this? Oh, I see why that probably works. Okay. Yes, because then this is cute. Oh, this is really cute. This is just a, this is a perfect square trinomial, no? So this is ln of x minus 1 squared all over 1 plus ln squared of x squared. Which, yeah, look, that's exactly the right thing, right? So how I identified this, for those, maybe you're like wondering, like, what the hell?
You done messed up, Aaron!
Right? This right here looks like, for instance, if a was equal to ln of x and b was equal to 1, then a minus b squared would be equal to a squared plus b squared minus 2ab. And that's literally what we have, right? So, yeah, and then this comes out to be ln of x minus 1 over 1 plus ln squared of x, all squared, which the integral of f prime of x dx is just equal to f of x. This is a fundamental theorem of calculus. So, there you go. That is your answer. Cool. Feels dirty. I guess it works, but I'm not happy with it.
Well done! Well done!
Kind of a cheating way to do it. Yes, I do need to hydrate. Thanks, Sam. I forgot I do have stuff. All right, cool. That was pies. Tell Jamarcus he's up. Wait, where's Jamarcus? Jamarcus, you not in my Discord anymore, Jamarcus? Jamarcus, what happened to you? Here, I'll ping you this way. Is Alistair or Discord? Is Alice? What do you mean? Is Alistair? Who is phone? What? Is Alistair or Discord? What is Alistair or Discord? Oh, is Alistair on Discord? Yes, Alistair is definitely on Discord. Yeah, you can literally see him there. Okay. All right, here we go. This is apparently a BC calculus question. I don't know. Consider the following procedure. Begin with a closed interval A1, B1. Bisect I1 to obtain two subintervals. It's set theory. But set theory is not covered in BC Calc.
Surprise, motherfucker.
Absolutely not. I have no clue what a Cantor set is. Okay. So, yes. So you can go from A1 to the midpoint, and then from the midpoint to B1. Select one of the two subintervals, call it I2. Is A2, B2. Keep repeating this process to obtain a sequence of intervals. I1, 2, 3, 4, 5. Show that the nested sequence of intervals obtained above satisfies both hypotheses of the nested interval theorem. That is this is not a BC calculus question. This is not. This is what? This is set theory, dude. Excuse me? Dude, how is this? Dude, what? Excuse me? It literally says it's BC calculus, the bisection method. In what world is this BC calculus? Ugh. A sub n is, so one term is always less than the next term for all n or natural numbers, so that, yeah, I don't know what these symbols mean. What? I is a subset of 2, is a subset of I3. Okay. I'm punting on this. I don't know how to do this. Nope, not today.
You're not that guy, pal. Trust me. You're not that guy.
Not today, Jesus. It's just a bit of analysis. Yeah, I haven't taken it out. Okay, so I was talking with Zach earlier. We were planning out Pi Day and some fun stuff we're gonna do. So stay tuned. There's gonna be some really cool announcements. But let me give a shout out to Zach. We were talking about maybe like doing a skill trade thing, because he really wants to learn E&M, which I teach E&M at UCLA. Like I've literally run courses for E&M. So he's like, oh yeah, you could teach me E&M, and then I could teach you anything you want to learn in math. And I think in math, the courses I did not take in college, I did not take real analysis, I did not take discrete, and I don't know how I got through complex analysis, but I did, and I think I would like to know better things about it. Yeah, it definitely looks scary. Yeah, okay. Feminist, you're up. Let's do Feminist's question. Oh. Feminist. Isn't this just a Gaussian integral? This one? This is well known. 6'2" feminist. Isn't this? Zach answered fem. Oh, yeah? Is it the square root of pi? Is this what this just is? Solve it. I'm pretty sure this is just a Gaussian integral. This is just known. Is there a funny way to do this one? Sorry, I missed it in chat if Zach did it already. Goated physics guy, make me some more vids for me this semester. I need to make more physics videos. I've been like concentrating on math so far, but yeah, okay, apparently it's just the square root of pi. You can show it by multiplying it by itself and forming a square. Okay, let's try that. I'm actually kind of excited about that. Square that bad boy. Okay. Multiply it by itself. What am I gonna say? I'm gonna say that. What's up, Star Prod? Wait, it gives a double integral. Turn it into a polar integral. Many different ways. Chat has a lot of different answers. Okay. Am I supposed to say, for instance, that A is equal to the negative infinity to infinity? Yeah, you do once and just forget about it. Like it didn't happen. And you want me to multiply this by e to the minus x squared? Is that the trick? No, multiply it by itself. You mean multiply the whole integral by itself? Determine a squared. Okay, alright, so, okay. Sure. Do I want to change these variables, though? Like, let's make this one x squared, and then I want this one to be, I don't know, let's say, for instance, e to the minus y squared dy. Aha! Okay. I can kind of see where this is going. This is actually pretty cool. You are right. It is a double integral. Or here, let me make all these colors blue, actually. Sorry. Cool. Okay, so then this is negative infinity to infinity, negative infinity to infinity, and then this is e to the minus x squared, e to the minus y squared, dx dy, yeah? Uh-huh. Okay. So then this is the same thing as e to the minus x squared plus y squared, dx dy. Okay, which this describes infinite space, right? I see. We're going to do a change of coordinate system. That's actually really cool. That's really cool. Exactly, right? Yeah. So dx dy from negative infinity to infinity, right, is spanning this whole area, right, from x to y. Over the x and y axis, right? So one cool thing to do is change the coordinate system. This is a useful trick in calculus. So instead of dealing with things in x and y, we're now going to deal with things in terms of r and theta. So this is going to be, for instance, like r, and this is going to be theta. And so if x is going from, so if x and y go from negative infinity to infinity, then r goes from 0 to infinity, and theta goes from 0 to 2 pi. I know there's a fancier way in math to write this, but I'm just writing it in English for now. Just integrate by integral by parts, dude. Why would I integrate by parts here? I don't think I want to do that. Wait, are you saying on the original one you can do integral by parts?
Nice.
What's would you choose one? Is it just e to the minus x, e to the minus x, and then you integrate one and you derive the other? I don't know if that works. wave 8. If you want to show me if it does, that's cool. Okay, so in that case, x squared plus y squared is equal to r squared. And, like, dA, which is equal to dx dy, that's equal to r dr d theta, I believe, right? This is the conversion for doing dA from Cartesian to polar. You can get this by doing, I want to say it's like the Hessian or something. There's a way to do it. Jacobian, that's it.
Oh, yeah.
Some other, like, weird name with, like, matrices. Okay, cool. All right, so now we're going to go from, let's do 0 to 2 pi d theta. Let's go 0 from infinity dr. And now this is e to the negative r squared times r dr. This is beautiful. Because this is u sub. Anytime you see something that looks scary, but you see the derivative of that scary thing also showing up somewhere else, that should tell you right away it's just u sub. So you can say, like, let u equal to, let's just say negative r squared. Then du is equal to negative 2r dr. Okay. So now you have the integral. 0 to 2 pi. This is still going to go from 0 to infinity. And now it's going to be e to the u. And then dr is now negative 1/2 du. And then we still have the d theta in there. Or negative 1 over 2r, sorry. Yeah. And then this is technically... There's technically another r here. But then the r's cancel. Math looks scary. Can I sub the entire math with you?
Good
Is that your Valentine's Day pickup line for me? Psychode? Oh, yes, technically. So here's the thing. I usually don't actually worry about these Hamiltonian because I'm just going to switch it back before I do it. I know the proper way is, yeah, I get it. So if u goes to infinity, sorry, if r goes to infinity, then u goes to negative infinity. You're very correct. You are correct. It should be negative infinity. Yeah. But okay, cool. So what do we get out of this whole mess? Your math line for your pickup line for math nerds. Okay. This is 0 to 2 pi, 0 to negative infinity, and then the integral of e to the u du is just e to the u. So you just get e to the u. And then d theta. So, cool. I could just, like, plug this back in, though, right? If I wanted to. You get the same thing. Right? If it was negative r squared, but then it goes to infinity. Okay. All right. And then the integral of this, right? Or sorry, this is not integrated anymore. So this is bounded. This is 0 to negative infinity. So then this is e to the negative infinity minus e to the 0. This is 0. Because e to the negative infinity is the same thing as 1 over e to the infinity, which is the same thing as 1 over infinity. And 1 divided by infinity is 0. You're okay with that one. You predict 7 minutes. That's a very specific number, Jeff. Why do you think I'm going to spend exactly 7 minutes? 7 minutes in heaven? Is that what's happening? All right. 0 to 2 pi. And then minus e to the 0. But then e0 is 1. So cool. Then we have a negative 1. Then d theta. This integral is just going to be theta from 2 pi to 0. So you end up getting 1/2 times 2 pi. So you just end up getting pi. But this was equal to a squared. Right? That's kind of the whole crux here. So when we took our original integral, we did the integral of a times a, which is a squared. And we found out that was equal to pi. So a is equal to the square root of pi. And thus, the integral from, what do we say? From negative infinity to infinity of e to the negative x squared dx is equal to the square root of pi. Cool. That's actually really dope. I've never done that before. Thank you for the question. Thank you, Fem. Another feminist that's not Femvox. So we have another person named Femvox fan that's been in our community for a while. So I might call you both Fem. But why is pi showing up there? Oh, good question. So why did pi show up? Pi showed up because when we did our coordinate transform here, Alex, or anti-electron, sorry, we were first integrating over the whole space in Cartesian, right? So in terms of dx and dy, we had to go from negative infinity to infinity, and then from negative infinity to infinity. But I decided that I don't like doing this integral in Cartesian. So I did a coordinate transform. So instead of defining things as like the distance along x and the distance along y, I put things into polar, which means now I define points as how far away from the center they are, which is r, and then what angle they are from the x-axis, which is theta. And so when I do that, xy used to go from negative infinity to infinity. Those were my bounds, okay? But in polar land, in order to cover the entire space, r now needs to go from 0 to infinity. And then theta, to cover everywhere on the 2D plane, needs to go from 0 to 2 pi. So that's why you end up popping out a 2 pi here as one of your bounds instead of all the infinities. And then it so happens, right, when you do this integral, eventually you get to this point where you're literally just left with d theta 0 to 2 pi, and that's where the 2 pi comes from. And then, yes, there's also a 1/2 that pops out, right? The 1/2 pops out from doing the integral with respect to dr, and then that kills it off to become pi. Yay, what's up? Yeah, Penn Center's here.
Good job.
Nice. Cool. Yeah, that was a really cool question. I really like that one. I like polar land. Yes, but in the end, why polar coordinates to work out in that specific equation? Okay. The reason why, and this is a good thing for math intuition, Auntie. I'm glad you're asking this. When you're doing integrals, and they look tricky, certain things should be hints that move you towards a certain like trick for solving them. This is a lot of math is pattern recognition. You're recognizing patterns that lead to certain techniques that work. Whenever you see x squared plus y squared, that should instantly tell you that you're doing something with some sort of either trig function, or you're doing something in cylindrical, polar, spherical, whatever. I call it like curvy land. Because what you know is that x squared plus y squared is equal to r squared. Right? And that comes from, in polar coordinates, right? X is equal to r cosine theta. Y is equal to r sine theta. So then x squared plus y squared is equal to r squared cosine squared theta plus r squared sine squared theta. And then this becomes r squared cosine squared theta plus sine squared theta. And then this is just 1. And so this is where x squared plus y squared equals r squared kind of comes from. So that's why they work out so well. Anytime you see this, you should think, okay, let's just try it in polar. And it turns out it's beautiful. It's actually really cool how it works. And I assume we squared our problem so that, yes, that's another trick, anti, which again, I didn't know. When I saw this a question off the bat, I was like, all right, cool. I just know what the definition is. But that's one of the tricks that they do. And you will do this in other sorts of math questions, especially where like the integral is weird. You can set the integral equal to something, and then you can work on both sides to try to get something nice. I think the classic... Here, let me show you another one that's actually kind of fun. Oh, what's your username, Jamarcus? So let's say, for instance, you want to take the integral of a to the x dx, right? This is kind of a hard one. Or no, sorry, let's not do the integral, sorry. Let's do the derivative Okay, here we go. Here we go. Find the derivative. Oh, I remember. Yeah, because you joined some Discord, Jamarcus, where you needed your real name. Santa's a poser. He didn't take calc. Okay. Let's say they want you to figure out the derivative of a to the x, right? This is kind of a tricky one to do. Something we do here in math is I say, okay, what if I were to call this something? Let's say b is equal to a to the x, okay? And then one trick I know about x being up in the exponent is that logarithms are really useful here. So let me just gut instinct. Let's take the ln of both sides. So now you get ln of b is equal to the ln of a to the x, right? And then this would just come down. So you would get ln of b is equal to x ln of a. And now what you can do is you can take the derivative of both sides with respect to x, right? Let me think how to do this. So derivative of this, so this is 1 over b db dx, right? And then this would be equal to you just e to the x ln of a. Was that the one we do? I wanted to do it this way. I think it's a cool way with doing with ln's though. Because then I'm going to solve for what db dx is. I think it works this way. Or I guess, well, this is going to become like a... Oh, a is a constant though, right? Yeah, we assume a is a constant. B is obviously not. Okay, watch. I think this still works. Yeah. Right, good. Yes, and then so this is just equal to ln of a, right? Okay, cool. So db dx is equal to b ln of a, right? Cool. Is it from mathematical approximations? I don't think so. Oh. Yes. Okay, and then remember, yeah, okay, we got it. And then remember, b was equal to a to the x. So, you get a to the x ln of a is equal to db dx, which is the same thing as derivative of a to the x dx is equal to a to the x ln of a. There you go. Yes, that works.
Good job.
Yeah. So that's another way to do it. Set something equal to it, do operations on both sides, and then do the derivative. That's what we did here. We took the original integral, we called it a. We did some algebraic thing to it. In this case, we squared it by multiplying it by itself. That turned it into a double integral. That was a lot easier to solve using a cute little polar transform. And then that was easy to then solve. And then we just take the square root of it, and then we get what a was. Okay, sorry, Sam. Loki, hear me out on him. Hear me out on what, Sam? What do you want? Exactly, Jeffrey. Yeah. Oh, Hamiltonian says you could also say E is equal to the A is equal to E ln of A. Yes, that's another way to do it. Yeah, so this is me trying to remember off the top of my head. I think the easier way is A is equal to E to the ln of A. Okay. And then taking the derivative of both sides. Is that what you're doing? So dA dx is equal to, and this is a chain rule, right? So this is E to the ln of A times d ln of A dx, right? And then this is, wait. d ln of A dx. Yeah. Wait, there's no x on this stuff. Wait, what? Oh, I'm missing an x. Yeah. A is equal to, oh, a to the x is equal to x ln a. There you go. Yeah. There we go. That's what I wanted. Yeah. Okay. Got you. So then that's d dx of x ln of a. And then this is just equal to ln of a. Okay, cool. All right, so then you just get a ln of x. This is another x. Sorry. I'm butchering this.
You done messed up, Aaron!
There you go. All right, that's it. Yes. There you go. Okay, cool. That's another way to do it. Good question, though. With their anti-electron, thanks. Yeah, you're very welcome. Cool. All right, good. Awesome. Yep, nice. Yeah, the question was too hard. The question is not BC calculus. Yeah, I can't do it. The question you have is set theory, dog. Like, what? It's not BC calculus. It's 100% not BC calculus. Here, Pen, if you want to take a look at it, I'll tag you in my Discord. Where was his question? I think it was... Did I still have it up? Yeah, this is it. Here, if you want to take a look at it, Pen. Yeah, this is not... Set theory is not BC calculus. It's just not. Yeah, it's real analysis, exactly. Which I haven't taken real analysis, so I can't help you with that, unfortunately. But here, I'll tag Pen Center Jamarcus in it, in the channel. So here, I'm gonna tag Pen. Or here, you know, I'm gonna tag the Math Gods. Apparently, this is very much not a BC calculus question. Yeah, so there, it's there. Yeah, you can ask ChatGPT, sure. Yeah, if it's due by Wednesday, ChatGPT will solve this by tomorrow. With how our bot works, it'll do it. Is this a calculus question? Yeah, here, it's funny. I could ask this. Here, let's ask chat. I'm actually curious about this. Let me ask chat. Is this a BC calculus question? I mean, it does involve series and sequences and stuff, but it's really sets. Pen says this is not. Dude, ChatGPT says this is absolutely BC level calculus material. Get the fuck out of here. No, it's not. It's okay, dude. This is maximum cope here, dude. Look at this. Chat says it's labeled BC calculus, the bisection method, which already puts it squarely in the AP Calc BC track. Go home, chat. You're fucking drunk. Dude, what? No. Dude, it's so brain. Yeah, exactly. I know what it did. It read here saying, "Oh, this is BC calculus." Let's see how. Using the supremum and the infimum, this is real analysis, dog. This is not calculus. Bro, it says BC in the photo. Are you dude? It reminds me of that recent thing that came out in the Epstein files, where Elon's getting invited right to the UN party, and Epstein literally emails him back, being like, "Are you do you think I'm retarded?" You had a whole unit about the supremum and infimum? Yeah, not a BC calc term. Yeah, it's not. Definitely not. Okay. But, you know, I will let the math gods like try to like put in their 2 cents. I unfortunately, Jamarcus, you have our whole table sat there staring at each other, yeah, I would too, dude. Dude, one of you needs to have the balls to like call your teacher out and be like, this is not calculus. This is set theory. This is real analysis. I'm sorry you're being debated in calculus. What's up, Coolest Dude? Hey, dog, quick question. But do you have any of your old high school notes, or do you just burn them in the summer of 12th grade? Yeah, I don't have any of my high school notes. What? I think the only notes I still have on me are... at this point in time, the only notes I have are maybe from grad school. But yeah. If you're going into college, like, I would maybe save your calculus notes. Those might come in handy. Then again, you guys have the internet and YouTube. Like, you can go find stuff again. But if you have, like, ways that you learned things that made sense to you in a certain way, you should probably keep your notes on that. This is the pain of IMSA torture. I haven't been able to sleep before 1 a.m. for the past 2 weeks because of the homework. Yeah. I have debates on this, Jamarcus, because again, I'm glad you're in a program that challenges you, because you are very bright. You're a very bright student. Like, don't get me wrong. You're a very bright kid. You're driven. You like math. Cool. I think you should be in programs that push that, but I think this is pushing it too much. And you're not allowing yourself to be a kid. At some point, being a teenager and like that whole growing up experience is still valuable as a person. There are actually some interesting studies on these kids that are like quote unquote prodigies as like young people and whatnot rarely turn out okay. They usually turn out actually pretty fucked up.
Disqualified.
And it's because there's like too much pressure on things that the rest of the social other things don't develop. And then who cares how smart you are if you're not able to communicate it or like talk to people. Yeah, literally just take calculus with me. Yeah. Well, Gladiator, Jamarcus is in like 9th grade. Very smart kid. Jamarcus is very smart. And I was also in high school. I was in a advanced math high school. Totally cool. But they weren't trying to push real analysis on us at 9th grade. Yeah, you skipped. I also have mixed feelings about skipping grades. I think that's also detrimental for people, for kids. Because then your peers aren't your age anymore. And there's a lot of other development. I mean, again, you may be at the math level of a 10th grader, but all the other stuff doesn't necessarily jump as well, right? And especially when you get to college, these kids that go to college and they skip like 5 grades, I'm like, congrats, but you're like, 17 when everyone else is 22 and 23, and those are very vastly different experiences in life. At least for like forming bonds and connections and stuff. It's totally okay to take advanced classes like outside of your regular curriculum, but you should grow up with kids your own age. You really should. There's a reason why we do it. Yeah, skipping 1 grade max is acceptable. If you skip more than that, your social life is fucked. 100%. Like, imagine everyone else is 5 years older than you and like your balls haven't fucking dropped yet. Like, there are certain things that you can't just rush through. Anyways. Yeah, my tutoring student just went to college at 15. Like, congrats. They're not going to have a fun college experience. They won't be able to drink until, like, you don't have to drink to have fun. But, I mean, it's part of the experience. There are a lot of things that require you to be a certain age. And if you're 15 in college, you're not going to be able to experience those. First of all, you're a minor. So now you need a parent's permission slip to do anything. Like, you don't even have executive function over your own body at this point. Yeah, and then, yeah, make sure you enjoy the other things as well. Yeah, it's okay to, it's awesome to study. It's awesome to be passionate about math. It's awesome to be smart. It's awesome to take advanced classes. Yes. Just please consider that you also need to, like, grow up as a kid. I see it too much. I see it from my end. I see really brilliant, smart kids who just don't get the development socially, and that's arguably the same level of importance. Yeah. Anyways, yeah, okay. Yeah, allowing them to skip grades, more gifted resources. Yeah, exactly. Yeah. I agree. The problem for me was my homeschool was shit. Yeah. Also homeschooling it. Don't do homeschooling. I have another opinion about homeschooling. I mean, yeah, if you have no other options, then maybe homeschool. If everything else is terrible, but you should also be interacting with kids your own age and I don't know other people and not just your parents. Because they only had 10 and 12. It's okay. Yeah, skipping one grade's fine. But maybe call it. I'm just saying be wary. Be wary. Be wary that your childhood is not getting just skipped over for the sake of you learning real analysis like 5 years before everyone else. Dropping in to say my exam, which I had yesterday, still today for you, went really well. Watching your streams definitely helped. Thanks, Jade. Yeah. No, I agree, Fanatic. No, homeschooling can be very positive. If it's done the right way, it requires a lot of effort. You know, you got to make sure that the homeschooling kids still go do outside of schooling things and still make outside of schooling friendships. You know, all these things are important. Good job, Jade. Yeah. How do I go about HLAA? I don't know what higher level A. I don't know what AA math is. Alcoholics Anonymous? What? In Penn Center. I wasn't calling you out for saying we can't have fun without drinking.
You done messed up, AA Ron!
Nice. Okay. All right. Sorry. End rant. All right. Let's try to do this question. This was from Asta. Oh wait. Partial differential equations? Oh no. I don't know that I can do PDEs. Ugh. That's another class I didn't take. I took DiffyQ. I think PDiffyQ is a whole other class, no? Or is this ODE? Is ODE? No, this says a partial differential equation. I said you'd cave in 7 minutes and it's been 6 since you brought it up. Oh, okay. All right, Jeff, you got me. Yeah. U is in 2 variables, so it is a PDE. What are you sending me, AFG? What is this? Oh, you solved it? Oh, brilliant. Oh. Bless you. Okay. So, Jamarcus, by the way. Yeah, no, that's Dyra. I tagged you. What was it? AFG is really nice. AFG wrote up a solution for you. Go check it out. Yes, linear algebra is great. I agree. Linear algebra is peak. It is the best of all the algebras. It's a great algebra. Okay. I don't know partial differential equations. I'm also going to pass on this one. It's okay. I will say the one thing... I play golf with my friends sometimes, and I'm decent at least like making contact with the ball, right? And I make sure I don't touch like the driving iron, the big drivers. I only touch the irons. And my friend's like, you know, I will say one thing about you. You may not be good at, you know, golf, Dr. Gold, but you at least like know your strengths, like you know your ability. And this is one of these things where like I know my ability in this one, and I don't know how to do this. And I'm not going to learn it really quickly. But this would be another thing that would be cool to do. PDEs to learn. Next one, you'll love it or you'll hate it. Let's see, who do we got? Ooh. I actually do like Maxwell's equations. You just whack the ansatz? Yeah, I don't know what ansatz is. Ansatz like the assumed solution? Oh, you will love it, but me will hate it. Okay. Cool. Alright, so if magnetic poles are discovered, that means div.b does not equal 0. I know that, right? Actual physics, no way.
Good job.
Yeah, this is an actual physics question. So, I want to say it's something with with these. I want to say this is the one that's wrong. Right, this says the path integral around the magnetic fields has to be equal to 0, which is similar to this one. Which, correct me if I'm wrong, is this Green's theorem? Which theorem is this based off of? You have like, yeah, this E dot dA is equal to Q enclosed over epsilon naught. This is showing that, for instance, a path integral around for the electric flux around the whole surface, right, has to be equal to like some charge enclosed, which is a pole or a source of electric field. Is it? No. This is Gauss's law. Sorry. That's what I meant. Sorry. This is Gauss's law. You're right. It's a surface integral, right? This is Gauss's law. Yeah. I was trying to. You're right. Anti-electron. I was starting to think about like Stokes or Green's, because those are kind of like based on things. So I think this would fail. Right, if you had magnetic poles, then this would be equal to like some like B pole, probably over mu naught or something. So I think 2 fails. So I don't think it's this one. It's not this one. Okay, so that gives us 3 choices. Think of them as happy little differential equations. Dio Brando, you will skip. I love Jeff. Are we gonna call you the weatherman? Are you the forecaster? Fanatic says I had a terrible professor for PDEs and I ended up not learning it. Yeah, I never took it, honestly. So maybe I will learn it at some point. Okay. What else do we think? Give them in a tarot deck. Yeah, Jeff's forecasting the questions I get asked, whether they're bad or not. Okay. I'm tempted to say 2 only. I don't really know where this comes into play. I know B dot ds equals mu naught I has to do with like currents. Is the third one Faraday's law? Yes, this is Faraday's law. You're right, KG. I know this is the, and we were talking about this yesterday. The visualization of divergence. So, for instance, yeah, divergence is there we go. This is what I wanted to show. This is actually really cool. So, for instance, yeah, divergence is 0 if you don't have any sources. Divergence can either be non-zero, which is positive or negative, whether you have sources or sinks. So, this is the argument for them having like magnetic monopoles, like having sources of magnetic field. All magnetic fields that we know about always connect back to each other. What's up, Clickbait?
Bing, 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 bang.
Oh, yeah.
Good to see you, Clickbait. And then we also had like a visualization of curl. Someone was asking me about curl yesterday as well. Curl is cool. So right, this curl measures like how much things like spin around something, which is useful for instance, magnetic fields spin around lines of current. And then gradient just like points to like where the peak of something is. How goes it? Yeah, it's cool. It's cool. I guess there's a little bit of E&M. But yeah, this points out like gradient, for instance. That's actually really cool. Oh wow, look at that. Yeah. Okay. So that being said, poles is div b is equal to 0. I know that would break this. I'm not sure it would break this. There's three. There's three. 3 AFG. Did you... If you post it in the queue, I'll do it. I think it's 2. Let me see this one. Let me see. Let's see what chat says. Grinding out some have you done perturbation theory yet? Clickbait? That's always the fun thing. No. Where's the link? There you go. Right. Okay. So we agree one would die. I agree with that. So 2. Okay. So then they say Faraday's law would also need to change. In differential form. Oh, I see. If monopoles can move. Yeah. See. Yeah, so I knew that 2 had to change for magnetic monopoles. I knew this had to change. I was curious about which other ones. I guess this one also has to change. Why are your images failing, Blue? What? Yeah, there you go. No, I have it. I see it. I see it. Okay, cool. You just finished degenerate states. We prefer to call them the United States. Oh, man. Okay. All right. So it's 2 and 3. I guess because you have to consider Maxwell's equations in differential form. So let's see what those are. Here we go. So blah, 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 blah. E.ds. Right. So this one comes from this. Is that because they're both yeah, so wait. So yeah, this is the no magnetic poles. No magnetic monopoles, right? So if this is wrong, then obviously the integral form is wrong. So that's why 2 is wrong. They said this one is also wrong. And I guess the argument is that you have to consider that the magnetic field can move based on if the monopole is moving. Oh, the Jeff joke. Oh, is that because they're both divergent? Oh, neurodivergent?
Surprise, motherfucker.
Okay. Right, because this would be dBdt minus mu naught Jm. Yeah. I got it. Yeah. The equations, you would have to be symmetric between E and B, so you would have to have a J term. For this one, you mean, yeah? Okay, cool. All right, yeah, that's why. Okay, so it is 2 and 3. Nice. Nice. Who was this? Dio Brando. Was this Dio Brando's? I like Dio Brando's. This is okay. Or no, sorry, this wasn't Dio. Sorry, this was Pineapple on Pizza is the Way. Yeah, I like pineapple on pizza. Anyone else like pineapple on pizza? I know, like, my Italian grandmother would probably be rolling in her grave if she heard I like pineapple on pizza.
You done messed up, Aaron!
But I you know what I really like? Pineapple on pizza with jalapenos. Like some sweet and spicy is really good. As long as it's not Ghislaine Maxwell Faraday.
Oh shit, not good.
Oh dear. No, I do like pineapple on pizza. You guys don't like pineapple on pizza? No, it's actually quite good. What? Really? I had a student I was tutoring. They're in college, but She really wanted me to help her with a class, and I really didn't want to. So she said, I'll order you a pizza if you do it. I was like, oh, okay. So she ordered a pizza for me, and she said, I'm going to give you my special pizza that I get. And I was like, okay. And it was quite good. It was pineapple with pizza with jalapenos. Here you go. I'll show you the pizza. You guys want to see it? This is it. This was the pizza. Pineapple. Oh, it was pineapple, pepperoni, and jalapeno. Pineapple on pizza with strawberries is peak. You had your students buy you Coke Zero. That's pretty good. That's pretty dope. All right. I don't think I've ever done strawberries on pizza. That's a little diabolical. Okay, big dog. What is this question? No. This is high-level abstract algebra, aka trolling. Okay, cool.
Surprise, motherfucker.
Well, it's going into the Discord at least. All right, Gladiator, yours is next. Hopefully something nice. It does happen. It is cool. I say once a week, someone asks me to solve. What is it? What question is it always? It's not the Collatz conjecture. There's another one that everyone always asks me to try to solve. It's a Millennium Prize question. Use the fundamental theorem of calculus. Yeah, nah, bro. That's it. The Riemann hypothesis. Oh yeah, I gotta get the fa noise. Yeah. Okay. Yeah, I will get it. I like this one. The Get Out Tuco one, but I will get the fa one. Okay, here we go. Beautiful. Oh, I love this. Here we go. Chemistry. JC's about to be so happy we have chemistry right now.
Baby voice is engaged. Okay, cool. Alright, we got baby voice too. Alright, draw a structural diagram, condensed structural diagram, and a line diagram for the following. Do isomers of all... Wait, what? What does it mean? Excuse me, what? Did somebody say chemistry? JC's so happy. That's not a diagram, that's acne.
Disqualified.
Yeah, what's going on here? I do need a drink. Thank you, yeah, JC. JC's like, hydrate up, dog. All right, JC, you gotta help me with this one, though. I mean, I know what C3H... I know what it looks like, but I'm a little confused what the other diagrams are. Okay, so C3H8... We do love the trolls. They're fun. Yeah, they are fun. I think that's just this, right? This is C3H8. Yeah, technically I'm working on them as well. I just haven't got anywhere. It's too old? Oh no. Okay, AFG. Alright, I'll take a look at it. Yeah, you are a loving troll. Yeah. Line is skeletal. Shout out to our loving troll pen center, by the way. I don't know if I've shouted you out yet, but... Pen Center's another awesome, amazing streamer. Again, if you found us from any of the platforms and you're asking your questions, go check out the website here, actualofficehours.com. You can submit your question. We're going to go through it live on the stream today. Also, there's a streaming schedule here, which has so many awesome things that are happening this week. So, MathPond is doing binomial options tomorrow morning. Zach is doing math through tasks. We will be streaming again. And then on Wednesday, Pen Center is going to do some Riemann surfaces. Lots of stuff. Zach's doing... Dude, there's so much fun, like, math streams and science and awesome stuff. So, make sure, go check out the calendar. Go follow everybody. They're cool people. Golden Pen are learning PDEs confirmed.
Disqualified.
if I submitted last stream? Yeah, sure. Do you not have credits to just buy the me first thing? That always works as well. Okay, so this is, I think, what's structural diagram, condensed structural diagram? I know what line diagram is. I think line diagram is, I want to say this. Because I think like each one of these little points here signifies a carbon, right? And then you assume all the hydrogens are on it. I didn't know about it, but take all my money. More wasted coins. Alright, CAFG. And then is there more than one answer? I don't think so with the number of hydrogens. If there were a different number of hydrogens, I think you could put like double bonds and triple bonds on things, right? Right, so like C5H12. I think is just this, but then we just add like another 2 of them, right? Right? Here, I'll put it with colors so you guys can see. It's actually kind of cool. So in this case, I take my original thing, and then I'm just gonna like slam 2 more carbons in there with 4 more hydrogens, right? And that's gonna form now C5H12. And then it's kind of the same thing with C6H14. Just put another one. CCHH. Good. And then this is C6H14. And if you want to draw these, right? You need 1, 2, 3, 4, 5. So you need 1, 2, 3, 4. Is that right? Like 1, 2, 3, 4, 5. There you go. That's that one. And then for 6, it's 1, 2, 3, 4, 5, 6. Oh, what happened there? I need to do all the isomers. Oh dear. Isomers is like what, all the different arrangements of things? So are there other ways to form this with also having the same number of hydrogens though? Can you just do you can just do the isomers for the last one? Okay. Is that where, like, are you saying I can do like this? Does this still work? I guess it does, right? One, two, wait, too many carbons. 1, 2, 3, 4, 5, 6, right? Oh, okay, just all the different carbon arrangements. Okay, cool. Right, okay, so this one works. Does it work with the same number of hydrogens though? Sorry, this is H, right? This is H. Oh, I think I see. Because now this, instead of bonding to 2 hydrogens, each of these angels gets a wing or something, right? Yeah, these each get a hydrogen. There are 5. Oh, okay, cool. I just want to double check that this works. Right. Yeah, so watch this. So 3, 6, 9, 13, 14. So we're still okay. Okay. And then I think in terms of a diagram, how would you draw that? Sorry. I'm thinking, so 4 in a row. 1, 2, 3, 4, right? So I need 1, 2, 3, 4. But then here, I don't know, do you do like this? Is that what you do? Does that signify it? All it starts like just looking like scribble. Levi says yes. Okay, I believe you then, Levi. Thank you. Also, wait, what happened to my TikTok chat? There we go. Should come back. That is one isomer. Okay, there we go. All right, there's TikTok. Just blast everything in again. Okay. All right, so that's one. I think you could put it on the other side, right? You could do this. Is this technically a different isomer? I feel like it just looks like a mirror image of this one, though. No? Yeah, the that's called the chiral one, right? Yeah, this is the chiral one to this one side code, yeah? No, that is identical. Okay, never mind. Well, I agree, because you could just, like, flip it around. Okay, so let's... Okay. So you could have 4 in a row. You could also have 3 in a row, right? So we could do 1, 2, 3. And then... I don't know, maybe this? Wait, but this is the same as this. It's just rotated. Right? Isn't this just the same thing as this, just rotated? Huh. That's also identical. Okay, so I'm fucking up. What are the 5? You need a different connectivity of carbons. Okay. That probably means double bonds. I feel like that messes up. Okay, wait. Maybe let's do this. What about this? Is this different? Yeah, I don't think you can do double bond. I think once you start doing double bonds, you're going to screw up the number of hydrogens. That is different. Cool. Does that make sense, though? Right? 3, 6, 9, 12. Okay, cool. And then hydrogen, hydrogen, 14. Okay, cool. We got one.
My man.
Okay, so this is 1. This is 2. Hey, what's up, Math Pond? Shout out Math Pond. A new streamer amongst our groups. Just did a 24-hour stream, I think he did, earlier in the week.
That's dope.
Count the first one as an isomer as well? Oh, yeah. Sorry, this was an isomer as well. Yeah. Yeah, let's give ourselves credit where credit's due, right? This is 1. This is 2. This is 3. And here, I'll just put the hydrogens on it. Just for completeness, right? Oh, see, now you're naming them? Dude, what? Oh, man. Now you gave them names? Okay, I think the other one you could do is this. Oh, man, wait. Bro cursed at me or something. 2-methylpentane. Yeah, the naming is always, you look at like what's the longest carbon chain, right? So in this case, this is heptane because you have 6 carbons. This is okay. Wait, so this is 4. This is also 4 actually. Right? Isn't this also 4 technically? And then you have, well, it's actually really weird. Sorry, hexane, not heptane. Sorry. Yeah. Sorry, heptane is 5. I should make heptane, though. Let's do that. And actually, sorry, let me get... Dude, the hydrogen is actually making this really confusing. I actually don't like seeing these. Sorry. This is what I want. C, 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 C. Right, which this is equivalent to doing C, 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 but then having 1 on this and then 1 on this. You see how this is equivalent to this? Because you can kind of like draw like a path. You look for like what's the path of the most carbons. See, that's a path of 4. But when doing this, you have like this thing and this thing sprouting off at the 2 and the 3 position. And then here, this is sprouting off at the 2 and the 3 position. Okay. So actually, let me draw this a better way, because I do like them in a line. Sorry, so this was C, 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 but then a C and then a C. We could do one with 5. So let's think maybe like C, 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 and then C? This is 1, right? Because that's 4 with a double. Do we have 4 with a double? We don't. All good. Could you do 2-methylpentane? Yeah. 2-methyl. Wait. So I think that's this. 1, 2, 3, 4, 5, and then this. Is this is also 1? Yes, this is 3-methylpentane. Let's actually just write them. Sorry, yeah, this is 3-methylpentane. This is 2-methylpentane. And then the cool thing about this, right, is that if I were to put this over here, that's not a new one. You wouldn't label this as 4-methylpentane because you always look for which one you can have with the least numbers, which would be going this way, and then this would be like the 1, 2. This would still be 2-methylpentane. Yeah, and then you can't do the cyclos because the hydrogens change. Okay, so then this one is, I want to say this is 2,3-dimethyl butane. Right, I think we do. I'm just labeling them now. And then this one, I think, is 2,2-dimethyl butane. And then, yeah, cool. This one is just hexane. 1, 2, 3, 4, 5. All right, cool. We did it. Nice. Good job, guys. JC's so happy we're doing chemistry. Shout out JC. Another chemistry guy who's super awesome. Yeah, all the anes. Very cool. Then we get to the ines and the enes. Okay, cool. That was Gladiator. You searched it up, you didn't understand? Yeah, awesome. Well, I'm glad it made sense. I mean, big shout out to JC. Thanks, JC, for helping me on that. Yeah, I remember that stuff a little bit, but I don't know, it's always like kind of shaky, so I appreciate you keeping me in check. Yeah, all good. What's going on, JC? How's life? Life being lifey? You got a lot of stuff? Yeah, we should get you. I will say, you're not missing out too much. Streaming becomes very popular for education, at least, in the next, I would say the next 2 months. Yeah, right around, I always have a big push around April, May. January and February, streaming is honestly like kind of dead because no one really needs help yet. It's when we get to the end of the semester. People are like, oh shit, I need help. And that's when it really pops off. Okay, let's see. What has DMs got me free? Alright. We got some fun ones here. Only the nerds are here now. Yeah, I mean, we still have people, but I could understand if you were a new streamer. Streaming in January and February is kind of rough because you're going to be speaking, especially if you don't already have a community. You're going to be talking to the void for a lot. Luckily, you know, we have a really awesome group of people here, and we do try to encourage more people to stream. So if you do start streaming, we will send our audience to your stream so that you don't feel alone and don't have to talk to the void for 2 years. Were you always doing homework help for streams, or do you start with gaming? No, we always started with homework help. My friend was streaming gaming, and then we were noticed. This was during COVID, back in like 2021, or I guess like technically right after COVID. He was streaming a lot of gaming, and we noticed a lot of students were playing games with us, and they weren't like doing their homework. So then that's why we started this stream as, oh hey, if you get help with your homework, we'll buy you. At the time, it was Warzone. We were buying like COD points for kids, and then it just kind of evolved into its own little thing. I was talking to a board for like 1 month. I didn't know there was a community. Well, now you know, Math Pond. You know, that's why you know, we try to send as many people to your stream, and I'm sure you've seen Eric, Jeff, all the people. Mean Machine Rex has been nice to introduce you to us. I'm glad. What do I find gets submitted the most? Levi asks. It's mainly math. Just because math is the universal class. Everyone has math. But I will say, there are times where just how the algorithm works. If I say chemistry a lot, this stream gets shown to primarily chemistry people, or people needing help with chemistry, and then we'll just get like a chain of chemistry questions. Rex is the best. Yeah. So, yeah. But it is a lot of math. A lot of math. Okay. Looking at the table below, what is the common ratio? Yeah, say the word more. Say physics more. Yeah. Say physics. If you say it 3 times, I don't know, Newton shows up in your mirror and kills you. Start the chem chain. Do not say optics. Do not say optics, please. I don't need optics in my life. Don't do it. Have mercy on me, please. Okay. This, you have to, like, just divide things, I think, to find common ratios. Wait, oh, I put too many things on the screen. Tell them, guys. You tell them optics. Tell them you want optics. Okay. So the rate... Oh, this is way too thick. Damn, boy, she thick. All right, so R is equal to, I would say, like, AN plus 1 over AN. And Blue, what this means is you just look at, like, future term divided by, like, past term. Yeah. Assuming they're consecutive. Right? You have to assume they're consecutive. These are consecutive terms, right? And N is going up by 1. So, oh, so here you go. This is actually, we don't even need a calculator. We can just do this one, right? So, A2 over A1 is equal to 40 over 5 is equal to 8. Right, so the common ratio is equal to 8. Nice.
My man.
And you can see that, right? This times this is 8. I mean, you can't actually really see that this is times this is 8. That's actually kind of hard to see. But I can see that this is also 8. Yeah. Cool thing for if you guys are into like construction and shit, 0.125 is equal to 1/8. This is this comes up all the time. If you say like a 1/8 bit or 1/8 of an inch, it's 0.125. So then if I were to multiply this by 5, right? So watch what happens. Times 5, times 5. This gets me 0.625 is equal to 5/8. And that's why when I multiply this one by 8, I get 5. Yeah, just a little hint. Okay. Does that make sense, Blue? Why the common ratio is 8 there? This is fun. You could do it with logs, or anytime you notice you have the same base, just equate the exponents to each other. Do I offer help with bio? So it's interesting. Biology, I don't really know how to tutor biology, other than like tell you that the mitochondria is the powerhouse of the cell. It's biology, at least at the high school level, is a lot of just memorizing. So I don't know. It's hard to like tutor and memorizing because I kind of just like got to tell you just go make flashcards. If there's a question with biology that's math related ish, then I could probably help. Yeah, exactly. For biology, you got to get in front of a mirror and read the textbook 70 times and memorize. Then you become doctor. Yeah, exactly. Yeah, the intro bio classes are. When you get to cool things like genetics and, I don't know, maybe evolution or something, there's probably some more thinking involved. I will admit, a lot of biology seems like stamp collecting to me. It's just memorizing shit. which is why I was turned off to it in high school. At least there was very little math in high school bio, and I didn't really see the point of it. I was like, okay. But if you want to become a doctor, you got to know biology. Systems bio. Okay, maybe. Systems sounds like there's math involved. All right, solve this. So the best way when you want to solve these DMs is try to write this in terms of the same base as this. And what I know is that 16 is the same thing as 2 to the 4th. Yeah, exactly. Yeah. So there's a lot of differential equations with logistic graphs, carrying capacities, predator-prey models. That stuff is cool. That I can help teach. Maybe also if they're asking, I don't know, like how many ATP is made from this cycle or something. There's a cool way to do that. Or like concentration gradients. Phylogeny. I don't know what phylogeny is. That sounds like a French dish. Phylogeny. Okay. Is that like the study of plants or something? Genetics, definitely. For sure. There's math. Okay, so then this equals this. P plus 2 equals 4, so P equals 2. Nice. Given the equation y is equal to 3 div x, it's transformed 3 units down, 2 units to the left. What's the new equation? Study of what's related to what? Oh, is that just what?
Disqualified.
Study of what is related to what? Alright, these are 2 different types of transformations. You should be familiar with these, okay? So if you're transferring something like up, down, that means f of x becomes f of x, and then it would be like plus minus something. Where plus is up, minus is down. And then if you're doing left-right transformations, these are different. Sorry for the lighting, it's okay. This is f of x becomes f of x plus or minus something. And in this case, plus is to the left, minus is to the right. It's opposite.
Get out!
Yeah. Oh, okay, yeah. Genetics and inheritance. Yeah. So there's stuff with like sex-linked traits are really cool, or like the double chromosome shit, and then you're like doing weird probabilities. That stuff is cool. What did I major in? Physics. I majored in physics. Yeah. I really like chem though. Chem's cool. I'm a big fan of chem. Okay, so 2 units down, so that's going to be f of x minus 2. So that means we now have y is equal to 3 to the x minus 2. And then if I want to go 2 units to the left, so that's f of x plus 2. So that's going to be 3 to the x plus 2. So then you just like kind of combine the 2 different transformations. So your final thing. So doing both things is 3 to the x plus 2. And then you can say like minus 2. I did do a PhD in physics. Yeah, that I do have my PhD in physics. That's true. Yeah. You can go read it if you want. There's a on the website that people are submitting their questions, like right here. If you click on the bio page here, not biology. There's a link to my thesis if you want to go read it. It's been a couple years. So I can edit and write my own name. You do the PhD not to acquire like some special specific knowledge. You do the PhD because it teaches you how to solve something unknown with no real guidance. Like you have to do it all yourself. Learning how to do that is a very unique process. A lot of the things you guys do in school are, there's a teacher saying this is due, and like I need these grades by these things and do your homework and blah blah blah. It's all very structured. PhDs are a lot less structured, and you have to come up with the structure. So that you learn how to do that, which is you're learning to learn. Exactly, Math Pond. Yeah. I don't know if getting a job means you can get a job easier. I've actually kind of found the opposite. I'm like too qualified for certain positions. Like, I think it would be easier to get a job actually if I hadn't gotten the PhD. Because instead of spending, 8 years learning a very specific thing in plasma physics, I could have spent 8 years just climbing the corporate ladder and would probably be a lot richer, and I would have more job security. But I wouldn't be happy. And I think money can only buy so much at some point. So yeah, you do a PhD because you have a love of the game. If you love the game, then go do the PhD. Great. If your goal is to get a job and make money, don't do a PhD. I would highly recommend against it. Happiness is a big deal. Correct. Yes. Money buys 95% of everything? I don't think so. What? Where did I get my PhD from? UCLA. Dude, it's on my bio, dog. You can go literally find my... It says the university on it. No way, that's crazy. Yeah. Yeah, that's why I teach there sometimes. Because they know I have a PhD from there. I will say that. Yeah, having a PhD does help me get a job teaching at UCLA. 100%. But that does not make me a lot of money. Yeah, they actually pay peanuts. It's pretty terrible. But yeah, it is a very nice campus. It's beautiful, yeah. When I was going to grad school, I had 2 options. Actually, 3. I was waitlisted at MIT. I had gotten into Wisconsin, and I had also gotten into UCLA. But, so my options were like cold as fuck Boston, cold as fuck Wisconsin, or beautiful sunny LA. So I went to LA, of course. Okay. All right, so let's see this one. All right, write a transformation of this function if it is stretched by a factor of 2. Okay, stretched which way, though? Like, stretched horizontally or stretched vertically? Those are 2 different things. I assume they mean vertically stretched. Okay, so in that case, stretched vertically would be y is equal to 2, and then we would say 3 to the x minus 2. If you want to, like, stretch, like, horizontally or compress horizontally, you got to do stuff this way. I am a Bruin, technically, yes. UCLA's colors are also blue and gold, which I love gold. Blue was my favorite color, actually, before my Gilded Age. And actually, my 2 cars, well, I have 3, but the 2 cars I actually drive. My first car is blue. That's the car I had during UCLA, or during, before I got UCLA. And then my second car is yellow, gold. So I have both colors. Anyways, if you're looking at a graph, this is actually kind of an interesting thing. If you compress horizontally, it's the same thing as stretching vertically. UCLA parking is hell. Correct. Yeah, I paid a lot of money. What I do now, KG, is I live in like Brentwood, Sawtellish, and then I ride my one wheel to campus. I save. They don't even give you free parking. If you teach at UCLA, they don't give you free parking. You still got to pay like $300 a month. It's terrible. So I ride my one wheel to campus. So much cheaper. Okay. And then 3 units to the left. This is the, what do you do if you do 3 units to the left? Sorry. You add 3, right? Yeah, add 3. One wheel's sick. Yeah, I love the one wheel, dude. I'm a huge one wheel advocate. Yeah. They're great. Get one. If you can find one and they're not cheap for sure, but in my mind, it'll change your life, and especially all the money you'll save on parking instantly makes it worth it. Just alone, I had a one wheel for quite a few years, and then it got stolen Like someone stole it. Sucked. So I didn't have one for like a year, and then I got hired to teach at UCLA, and I was like, okay, well now I can justify spending another $1,000 on a one wheel because I would pay that in parking like in 3 months. So might as well just get another one wheel. Okay. What is the positive interval of this equation? Okay, well that's from here that way. Worked at a moto dealership when they came out. My homie crashed it through the parts counter. Yeah. Yeah, you can definitely fuck up on them for sure. I've been riding them for years though, so like I'm okay at this point. No. It's not. No. So if you're moving horizontally, you need to do stuff closer to the X, right? Right? So you have to, this thing is already shifted to the right too. So then if you shift it 3 to the left, it's technically shifted 1 to the left. Yeah, you missed the horizontally part. All good. You know what's funny, Clickbait? I saw some motorcycles on the street the other day and I debated. I'm like, I should go buy another one. I used to have a motorcycle in grad school. And then I sold it after like counting my blessings for not getting killed on one. This is probably like grade 10. I would say grade 9. Okay, what is the positive interval? I think they mean the positive value for y. I think they mean like y is greater than or equal to 0. Yeah, you have to be careful with motorcycles. It's not even that you have to be careful. You have to trust that other people are being careful as well. You have to... You can be the safest driver ever, but someone's going to be a fucking idiot.
Bruh.
And end your life, so you have to constantly be looking out and hoping other people are being safe. Yeah, exactly, yeah. No, I had the motorcycle in LA because traffic sucked, and in LA you can lane split, and so it was a godsend for me tutoring around LA. I could just split through traffic all the time. I loved it. But yeah, I'm fortunate I'm alive, so whatever. We'll take the wins where we get them. Okay, so I think I just need this intersection point, right? Because we know to the left of this it's positive and to the right of it's negative. So let's just set this equal to 0. So let's say 0 is equal to negative 2 to the x. Yeah, it is funny, KG. There's a good scientific paper on this about why motorists hate motorcycles, or they hate cyclists. And it comes down to humans don't like other people getting ahead, even if it's not really affecting them. Like a motorcycle going ahead of you does not affect traffic at all. But if it looks like you're getting an advantage and I'm not getting an advantage, you just naturally hate that person. It's super interesting. It is 2 by inspection, but you could also show it this way, right? Okay, so x is equal to 2.
Unexpected factorial. Surprise, motherfucker. So, interval is then negative infinity, comma, 2. There you go. Nice. Good job, James.
Well done! Well done!
Cool question. Yeah, I learned about unexpected factorial now.
Zach, because of you. Alright. AFG gave a problem. Oh, Jesus. Okay. Alright, we're going to see what comes up here. Second. Okay. Hope that helps you out, DMs. Oh, let me give points to you guys. And correct. We love the wins there. Oh, Jesus. An 8th lane?
Bruh.
That's nuts. Yeah, Texas has some pretty ridiculous ones, too. Is the course we answering right now is a schedule a program like Monday is no. There is no there's no set schedule. We answer whatever, any day of the week, as long as it's like somewhat math and science based. Amo Kayato. Okay, let's see. Next one is from AFG. Warning, the calculations are a bit messy. Continuing with a solid disk. Let T be the horizontal disk with the boundary of intersection of the sphere and the cone. I think I need more information about problem 2, AFG. Yeah, Zach loves multivariable. I feel like I need more info here, no? Can I do this one as is, Zach? Yeah, Stokes, Greens, all those ones, yeah. Practice is the only way to get good at these for sure. I don't know what's going on here. I want to say A square root of 2. I want to say that's... I don't know. Yeah, what is problem 2, right? AFG, we need problem 2. You missed one of the ones I don't know? Which one? What do you mean it was at the top? The common ratio? The common ratio is 8. Wait, what? Which one did I miss? I don't think so. Oh, describe the transformation. Oh. Yeah, because it didn't look like it was a question.
Bruh.
You done messed up, AA Ron!
Okay. Yeah, one sec. All right, let me finish. Let me do this one real quick. Yeah. All right, one sec. Yeah. This is not hard. Okay, so I like to work from closest to the variable outside. So right off the bat, the first thing I see is, horizontal right 3, or horizontal shift to the right 3. That's this. Okay. All right, and then what's happening is, okay, now it's getting, the negative is flipping, and it's also stretching. So you could say, like, flip over the x-axis and stretch vertically. Stretch vertically by 2. And then the last thing is vertical shift up by 4. That's what this is. Cool.
Good job.
All right, here, I'll put this in there. I'll put it on the same thing. Reflection to the x-axis. Yeah, that's another way to write it for sure. For sure, Amo. Okay. This question, I think I need more information to do. It is a Green's theorem question. I need more information about what problem. I need to know what the solid is. If I don't know what the solid is, I can't do integrals. Okay, so let's see what the next one is. Frick this. Quantum tunneling. Ooh. Man. I don't know if we're gonna be able to do quantum tunneling. Let me see what the other one was. Clickbait. Oh, okay. Given the matrix H0 and H prime in the orthonormal basis 1, 2, determine the energy eigenvalues and the energy eigenfunctions using perturbation theory. Oh, where H prime is the shift, right? Okay, let me just like walk through this one. Okay, so you have it act on a wave function yn. And then this gives you some base energy, some lambda. Yes, I definitely do kinematics. Amo, if you want to submit again, it doesn't have to be quantum mechanics. I know a lot of these questions look really difficult, but do not worry. If you want to submit something that's like more of a lower level physics question, you totally can. This is the website you go do it to. It's the actualofficehours.com. Quantum mechanics, man, I haven't taken in a while, and this is, I don't teach quantum. So, E lambda, it's easy. JC says it's easy. So lambda energy state 1 plus lambda squared energy state 2, where, okay, so then these are the states, the eigenstates. And then what? This is a twofold degeneracy. You can ignore the first 3 rows. Wij is equal to sandwiching psi I and psi j in the 0 state between the H prime operator. Oh, sorry, Zach, are you talking about the other one? For the last one. Yeah, I know what you're saying. For this one. Interesting that it becomes like a cinch thing, though. Where do you think cinch comes from? Oh, that's a standard problem? Okay. What level is the quantum tunneling problem? It's probably college for sure. I would say this is like maybe 2nd year of college, 3rd year college physics. I forget what the F and the A is. Is that like forward versus like reflection? All right, let's see. Okay. Yeah, energy. And if this energy is greater than the potential... Sorry, if the potential is greater than the energy of it, then, yeah, tunnels, and then you get something that's like a lower energy that makes its way through. Okay. Yes, WKB. Oh, yeah, here we go. Yeah, WKP approximation. Okay, that's where this is from. And this is where, yeah, imaginary kind of describes... Yeah, the imaginary is the oscillating part, right? And then the real part is the decay. It says this is exact. Okay. Uh-huh. Yeah, incident, reflected, transmitted. Uh-huh. This is all differential equations, yeah. Right, so you get 3 differential equations to solve here, right? So this is the Schrodinger equation for the region before it hits. Region before it hits, region when it's in the tunnel, and the region when it's on the other end of the tunnel. And then you have continuity, right? Yeah, okay. So the values of the wave function have to be the same at the boundaries, and then also the derivatives have to be the same. I see. And then, yeah, differential equations is always cute because you say, oh, I'm going to assume my solution is of this form. And then you can prove that it works because you just plug it back in and take derivatives. Uh-huh. Right. You have I to the kx in 1 and 3 because it's strictly a traveling wave. And then in region 2, you should have a decaying wave, right? Yeah, and then you have a reflected one. Okay. Okay. Right, and they call the amplitude of the transmitted as F. The reflected is B. And then A is incident. Okay, so then this is the transmission is F over A. Okay, fine. And then in region 2, you get this, right? So now these don't have I's on it. That's why these are strictly decaying functions. Cool. And then boundary equations, you solve for A, B, C, D, blah, blah, blah. The actual algebra that leads to F over A is pretty lengthy, but it can be done either by hand or the help of computer software. Gotta love that, the help of computer software. ChatGPT, yeah, well, your stuff is pretty basic. All right, so, yeah, there's some crazy algebra that eventually gets you to Kosh here. And I guess, yeah, it comes from because you have e to the... You have these e exponentials. Uh-huh. Okay. Great. Okay, cool. You know what I'm going to do? I appreciate you getting this link for me. Thank you, Zach. I'm just going to post this link for the student because I'm not going to do this on the stream. This would take like 30, 40 minutes to do, especially the algebra part. But I will post it in. Sorry, where was it? And someone sent me an antiderivative. Okay, so one sec. Let me like post. And then clickbait for yours. Yeah, this I don't know. I'm rusty on this stuff. I don't really. I think JC has you on this one. So I'm gonna put this one also in the Discord. But then I'm gonna tag JC. If JC wants to like help you out with it. I would have to work this out myself before I attempted to stream if I tried. I don't know if I could do it without making sure I had the details exactly, yeah. Oh, it's already done. Oh, okay. Sorry. Are you just showing like how it works? I would say it's cool. This is why, yeah, this is also why it really helps to have a foundation in linear algebra. Do you see how we're getting matrices and vectors and everything? If you want to be quantum physics person, know how to do this. It's important. There was a part 2 that I was going off the rails on. Oh dear.
Surprise, motherfucker.
Oh dear. Let's see. What is who? Okay, I have 13 minutes left, and I would like to eat. I keep having to sacrifice my eating for teaching. Need to eat at some point. Let's see. Let's see what we got on the queue. Antiderivative. Problem of the month. It's a Waterloo question. Oh, I think I've seen this one. Oh, man. Isn't there something weird here where, like, if you rotate a coin, like, the distance is different? What is the Waterloo effect? What is it, JC? Tell me. Isaac Newton would have eaten some mercury. Let's just go crazy. All right, let me look up the Waterloo effect before I start doing more stuff. The Waterloo effect is a viral, unofficial term describing the intense transformation of University of Waterloo engineering students from freshmen to graduates. It highlights the physical and mental toll of demanding 5-year program. Oh, Jesus. Oh, I see. Like, young happy boy.
Good job.
And then, like, Jesus Christ. This man has the 1,000-yard stare. Mathpon says, in quantum mechanics, the Hilbert space is infinite. Does that make matrices irrelevant, or how do you calculate stuff? You definitely use matrices. Oh man, these are all the examples of it. Oh, that's hilarious. This person didn't age too terribly. Yeah. This person though, yeah, wow. They should have at least blocked the names, yeah. This is a pretty funny dude, man, damn. I think people are posting it themselves. They're doxing themselves. I don't think there's anything like unique here. I was gonna say I have a pretty funny picture of myself. Let me see if I have one where I think it was license. One where I have them where I think I blocked. No, that's my full information. There, here. This is my Waterloo effect per se. If you guys want to see, this was me starting graduate school, and then this was me ending graduate school. Or what I like to say is like, what happens if you live in Los Angeles for 8 years? I came in as like a nice innocent person, and then like started having dyed hair and all sorts of things. Baby gold, yeah, this is baby gold, yeah. I feel like I have another picture of my my passport photo is also funny, the difference there. Anyways. Yeah, here we go. Oh, this is a funny one. Okay, then I'm gonna end the stream. But I look like a scientist, yeah. Yeah, this is the other funny one. This is me, I think in undergraduate, and then this is me towards the end of my PhD. So maybe this is kind of like the Waterloo effect, I guess. Yeah. Anyways, okay. Any other questions? Any other cool ones? Nerd to mob boss.
Oh yeah.
Yeah. Oh, I can look at this one at least. I can look at this one. Yeah. I used to always joke with my friends. I say, do you ever look at yourself in the mirror and not recognize the person that looks back at you? I feel like that was happening a lot to me throughout graduate school. I even put it in my thesis. I thanked my advisor for putting up with all my different changes of hair color. Because I came into graduate school as one person, and then Los Angeles definitely did a number on me. And I was a very different person throughout many stages of my graduate career. But my advisor was cool with all of it, which is cool. He was a great guy. Picking the right advisor is like probably the most important decision you'll make in your academic life. Okay, let's see. Several dials are each labeled with integers 1 through 4 in clockwise order. The dials are arranged in a row and initially configured, so each dial has a 1 at the top. That's cool. It just says several dials, by the way. We don't even know how many dials it is. A move consists of rotating 2 adjacent dials in the same direction by the same number of positions. For instance, one possible move is to rotate the second and third dials by 1 position counterclockwise. Okay, so that means to take this and rotate it this way, and take this and rotate it this way. Cool, so we get that. There are k greater than or equal to 2 dials, and they are initially configured so that each shows a 1 at the top. Any tips to ace Waterloos? Probably just doing more Waterloo questions, honestly. My whole mantra for any of these competition math questions is pattern recognition. So if you want to get good at them, you just have to do them. It would be nice if this one had you can get access to a lot of the old ones and they have the solutions for you. That's the best way, I think, to get good at those types of questions is go look at the previous years, try to do them yourselves, and when you inevitably hit the wall and just want to rage quit, look at what the answer is, or like look at the beginning of what the answer is and then try to keep going. You know, it's like train to failure. That's how I would recommend it. In terms of K, determining how many possible configurations of the dials are attainable by performing a sequence of moves. What's a sequence of moves, by the way? Sorry. Am I allowed to perform as many moves as I want? Oh, number theory is probably really good. There's also a lot of fun geometry questions I see on Waterloo, where you have to like draw an auxiliary line or something. So brushing up on all the geometry identities are very important. Yeah, sequences. Yeah, sequences come up a lot. And then this is probability, right? How many possible configurations of the dial are attainable by performing a sequence of moves? I don't know. I mean, let's say we have like 4 of these, right? Yeah, number theory. Yeah, combinatorics. Zach's right. Yeah, Zach's right with those. Yeah. So, wait. Here's my question. I could rotate these 2, for instance, right? And then I could rotate these 2 as well, right? By the same number of positions. So I could get like 2, 3, 2, 1, right? Because these ones would stay the same. And it's interesting. So I'm seeing like a number theory thing here where it's cyclical, right? Like it goes 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So there's almost like a modulus involved. There's a lot of modulus stuff also. Oh, well, thanks, AFG. Yeah, that's what I needed, dog. What? The ice cream cone? Yeah, that would have been helpful. Yeah, I get the idea of what it's asking. So, for instance, yeah, so I usually like to take a base case. So let's say, for instance, like k is equal to, they said k has to be greater than or equal to 2. Let's assume just k equals 2. Right? Yeah, try different scenarios. Let's assume k equals 2. So if you have only 2 dials, right, and you always have to move 2 dials at the same time, right? They have to be adjacent. This gives you 4 possibilities, right? Or let's say like n, right? So then n equals 4. Because you could have 1, 1, 2, 2, 3, 3, 4, 4. Okay, cool. Let's assume k is equal to 3. So I start out with 1, 1, 1. So if we fix this one and then move these 2, I get 1, 2, 2, 1, 3, 3, 1, 4, 4, right? If I fix the last one, so this is like fix first. I'm going IT. How far math do I need? Any idea? Probably linear algebra. I mean, are you talking about like just fixing computers or like computer science? Yes, and now the trouble begins.
Bruh.
Now the fun begins, right? Because now you could have 1 and then you could have 2 2. Sorry. Well, 1 and 1's already counted, right? So you have 3 3, then 4 4. But then the interesting thing is once you've done this, no, well, this is meant for very advanced high schoolers. It's high schoolers who enjoy just like out of the classroom math challenges. Like they're passionate about just solving puzzles. It's like I don't know. Is chess meant for high schoolers? You don't learn chess in high school, right? It's not like a mandatory thing. But certain people like to spend their time learning how to get really good at chess. That's what I see these are. Like, you learn the foundational knowledge in high school, but it's for people who are bored with their high school classes and they just want to, like, do other... Like, math is a bunch of little fun little puzzles you can do. Yeah, you can do this as a tree, right? Yeah. Well, because, see, once you have this... See, once
we have this, right? I could then... So if I fix the first, I could then, move the last, right? So in that case, if I fix first, move the last. Well, actually no, sorry. Now fix the last and move the first.
So this one doesn't generate any new cases, right? Because that's already what we have. This one does though, right? Because now I would have 2, and this would be 2 3, and then I would have 2, and then I'd have 3 4, and then I would have 2, and then I would have 4 1, right? And then if we move 3 3, I get 3 2 4, 3 3 1, 3 4 1, right? And then I get 4 2 1 4 3 2 4 4 3, I think. Right? Exactly. Yeah, mix rotating the other two. Yeah. Because then you could also do this, right? You can like fix the first and move the last. In that case, you get 2 3 2. Oh, but that was another case then, right? No, that's already the same one. 2 4 3. Oh, interesting. Oh, those are the same ones. Okay. Do you see how this is actually symmetric then? Right? If Oh, thanks, Derivative. Appreciate it. Oh, yeah, shit. Actually, sorry. I'm out of time. Sorry, I'm over. Okay, I gotta go. Alright, let's close out the stream. Alright. Thank you, everyone, for coming to Actual Education Office Hours. Appreciate it. All the cool questions. Yeah, AFG, I don't have time for that one, but I will post them to our Discord. So that is the advantage. I will put this in the channel. Where was it? There you go. This is it. Okay, cool. All right, there, AFG. I put it in there. Here, and I'll tag the math gods. Maybe one of them will feel nice. Wait, why can't I tag them? Okay, whatever. I'll figure it out. Anyways, yes. Okay, cool. All right. Yes, thank you, everyone, for coming. Our next stream will be tomorrow. That's going to be at 6 p.m. Pacific, 7 p.m. Mountain, 8 p.m. Eastern. Is that right? No, 8 p.m. Central, 9 p.m. Eastern. Yeah, a little bit later tomorrow. So come on by, get help. Make sure go check out the other streamers we have. We got a lot of people streaming tomorrow. MathPon will be on. Zach will be on. So yeah. There you go. 1 a.m. GMT. If you're watching us on Twitch, which I highly recommend, we're gonna go raid somebody real quick. Let's go see who we want to go raid. 2 a.m. Just, you could always just do time UK. This tells me what it is. Yeah, right now it's almost 4 a.m. So yeah, it'll be about 3 or something. Okay, let's see who's on. Do we have any math or science people doing stuff? Yeah, physics and impression's doing stuff, right? Where's physics and impression? Amateur music analysis. Oh, that sounds cool. Cool. All right. Zach is on. Yeah, he's on Tuesday. Again, go check out the calendar. The calendar has all the times that people are streaming. All right. Cool. All right. Enjoy the rest of your Monday. We'll see you tomorrow. Peace.